Hello dear students, in our today's video we are going to start with the first topic, that is rotational dynamics. It has weightage 5 marks and with option 7 marks. Okay, so in our today's video we are going to just introduce some concepts which are included in this topic, and also going to review the topic related to motion, okay, which we have already studied in the 11th standard, that is motion in a plane. Okay, as you know, this year the physics syllabus has been changed. Earlier there were two topics named as rotational motion and circular motion. In the current syllabus they have been merged and named as rotational dynamics. Okay, so let us see what is included in this topic. Here are the contents, that is total 11 articles are there, starting from introduction, characteristics of circular motion, okay, applications of circular motion, that is UCM, vertical circular motion, then moment of inertia, radius of gyration, parallel axis theorem, perpendicular axis theorem, angular momentum, torque, conservation of angular momentum, and rolling motion. Okay, among these this sphere of death and vertical and vehicle at the top of a convex over bridge, these two articles, sub-articles of article number 1.4 are deleted or reduced only for the current year due to COVID. And here another article named as rolling motion also has been reduced for the current year. Okay, so up to circular motion we already have studied this as introduction in 11th standard. So let us see, in particular in this topic, that is rotational dynamics. As I said earlier, this topic was also named as circular motion and rotational motion, individual topics. They have been merged together to form a single topic that named as rotational dynamics. Okay, then what is basically the difference in kinematics and dynamics is that when we are considering any motion and also considering the cause behind that motion, okay, so cause means that particular force which is responsible for that motion, then that study of motion is related to dynamics. Okay, that is dynamical study. And when we are not considering the force which has been responsible for that motion, okay, we are neglecting or ignoring that force terms, then it is a kinematics. So up to now in 11th standard we have studied the kinematical part. Whenever there is a introduction or there is some terms related to force, then it will be directly converted to dynamics. Okay, so particularly in this topic we are going to again study start from circular motion. Basically the rotational motion is also a circular motion, and revolutionary motion is also a circular motion. The basic difference is the axis of rotation, that is imaginary axis of rotation, about which the particle or certain object or any body which is moving in a circular path. Okay, so that depending on the position of that particular axis of rotation, it will be decided that the motion is either rotational or revolutionary. Okay, so here you can take a simple example of planets moving around a sun. This can be taken as simple example. Okay, suppose this is our earth, totally the circular path we are showing. This is complete earth, and the dot in between the center is supposed to be an axis of rotation passing through it. Okay, and this earth is, as you know, it performs both motions, that is rotational as well as revolutionary motion. Okay, rotational motions means suppose all the body particles or all the particles over the circumference of that earth are performing rotational motion, and suppose the axis of rotation is lying within that body. Okay, and here is the case, suppose it is at the center there is sun and earth is revolving around it. Okay, so here earth is also performing rotational motion as well as the revolutionary motion, because when it is performing rotational motion the axis of rotation lies within it, and when it is performing revolutionary motion the axis of rotation, another axis of rotation is lies outside the body. Okay, outside the body at the circular, at the center of the circular path. Okay, so this is the difference, that is in rotational motion the axis of rotation lies within the body, and in revolutionary motion the axis of rotation lies outside the body. Okay, so further in this topic we are going to discuss about UCM and non-UCM, that is uniform and non-uniform circular motions. We are considering certain examples of horizontal circular motions and vertical circular motions. Okay, then dynamical parts. Further we are going to also discuss banking of rods, conical pendulum. Okay, and whenever there is introduction of the force which is responsible for this motion, that is the dynamical part, that is dynamics of circular motion. We will introduce centrifugal and centripetal forces, okay, which are responsible for these circular motions, uniform circular motions. Whenever we are considering the force, there, as we know from the Newton's law, that is force is equal to mass into acceleration. So this mass factor in certain rigid and earth symmetrical and symmetrical bodies, we can't take directly as a whole. Okay, so in that case we are considering the moment of inertia, mi, that is I is equal to mr square. Okay, you will know in detail when you are going to deal with that topic article. Okay, further we are also going to study in this topic parallel axis theorem, perpendicular axis theorem, and angular momentum and conservation of it, torque and rolling motion. Okay, rolling motion is reduced part for this particular topic. Now let us revise what we have studied in 11th standard. Okay, as you see here on the screen, basically we must know what is motion first. What is motion? Suppose this is a body. Okay, this is a certain body. Okay, and whenever we are applying certain force on this body, it will move along this surface. Okay, right from position A to position B, means it is changes its position from one place to another place. So we can define from this motion that change in position of a body or on an object by applying certain force, okay, with time t is nothing but a motion. Okay, change in position of a body and or object due to certain force with time t, okay, is called as motion. So simply the motion is a change in position of a body with respect to time. Okay, now we can also further we can categorize or classify into three types of motions, that is 1D motion, 2D motion and 3D motion. 1-dimensional motion, 2-dimensional motion and 3-dimensional motion. So there we have discussed with certain examples, that is 1D motion is nothing but the motions which are along the straight line path, and 2-dimensional motions are nothing but with the motions which are occurring in a plane, and the motions which are occurring in space are 3-dimensional motions. Okay, so as we see the straight line paths, we have shown certain diagrams over there, and non-straight line, that is non-linear motions, 2-dimensional motions in a plane, and these are in space motions, that is circular motion. Okay, these straight line motions are also called as rectilinear or translational motion. Okay, and for describing these motions we have considered certain physical quantities named as distance, also called as path length. Okay, it was we were considering some by variable x or s. Okay, there are SI units, dimensions, and etc. We have studied over there with their definitions. Also, we have studied displacement, what is time, what is speed, okay, what is acceleration. With the help of all of these physical quantities, we were describing a certain motion, okay. And here we have not included or not studied the force part, okay, which was responsible for that motion. So this was all kinematic study of a certain circular motion or any 1D motion. Okay, after that we also studied the average, okay, average speed, average acceleration. Okay, it was just a calculation of summation of over the large number of values. And instantaneous any speed or instantaneous velocity, instantaneous acceleration, these were the values of that particular physical quantity at a particular given instant of time. Okay, at given particular instant of time. So just a second. No, I will continue. After that, also we have studied uniform these particular quantities, that is uniform speed, uniform velocity, uniform acceleration, and so on. And later on we have also studied certain graphs related to velocity and time. Okay, after that we have gone through motions in a plane. There we have derived certain equations of motions. Okay, they were as given by Newton's equations of motions, also called as kinematical equation of motions in a plane of object when with uniform acceleration. This is important. Okay, with uniform acceleration. So this was the first equation of motion, that is v is equal to u plus at, where u is the initial speed, v is final speed, okay, a is the acceleration, that is change in velocity, and t is the time required to total motion. Okay, so s is the displacement. Second equation of motion was s is equal to ut plus half at square. Third equation was v square is equal to u square plus twice as. After that, we have gone through certain problems and certain relative motion problems, that is a comparison between two physical quantities. Here we were studied the relative velocities, relative speed, relative acceleration, that is whenever we are having certain case of two bodies moving at a time and they are having certain velocity or acceleration. In that case, just a second. So we were studying here that we have studied in relative motions, that is comparison of one physical quantity with the another, which is considered to be as a reference value. So VAB, that is VA minus VB, we are comparing the velocity of A with respect to B and B respect to A. Okay. Okay, sorry for the interruption. Okay, after studying the relative motion, that is comparing one physical quantity with the reference physical quantity, we have learned also projectile motion. Okay, that is in that particular article we have studied whenever a certain object is under projectile motion, it is projected from one place, it takes certain time of light, okay, in which we were calculating the time of ascent and time of descent, and the maximum range over which it is reaching the or covering the distance, that is horizontal range, and the maximum height as h. Okay, after that we have gone through the introduction of circular motion. Okay, and also declared that we are going to deal with the whole topic of circular motion in next standard, that is in 12th standard. Okay, let us see what we have seen the introduction part in that particular 11th standard. Okay, so as you see here, motion and 3D motion, introduction in space, that is motion in a space. There we have considered this example circular motion as you know, the definition of circular motion is any body moving along the circumference of a circle, okay, is a performing circular motion, right? And it has two particular characteristics, as it is a accelerated motion and it is a periodic motion. Why it is accelerated? Since a body which is performing circular motion, okay, so it has velocity at every instant of time which is having constant speed, that is constant magnitude of that speed, and variable direction, because at every, you will find at every instant of time at that position it will having direction tangential to the circular path. It is towards outside the circular path and it is tangential to it, okay. So this tangential velocity, okay, is maintained by centripetal acceleration, which is provided by the centripetal force, okay. The centripetal acceleration, which is perpendicular to this tangential velocity and directed towards the center of the circle, opposite to the direction of radius vector, which is responsible for this circular motion, okay. So since the tangential velocity is variable at every instant of time, that is change in velocity, so we say it is an accelerated motion, okay. Further, it is also called as periodic because, as you know, the periodic means it's a certain time interval. The body that which is performing circular motion, it repeats its circular path, repeats that particular circular path, that motion in equal interval of time, so it is called as periodic. So these were the two characteristics of circular motion. Then as you know, as also already we have discussed that there were two main these factors, that is centripetal force and tangential velocity, are responsible for this uniform circular motion, okay. In non-uniform circular motion, you will find that this velocity is not constant, that its magnitude is variable at everywhere, at every point, okay. Further, we have studied related to the circular motion, that period, that is time interval, time taken to complete one particular rotational motion or revolutional motion, that t is equal to distance upon uniform speed, that is 2 pi r upon v. So translating exchanging these positions, we will get uniform speed v is equal to 2 pi r upon t, okay. Here t is your time period, not time, okay, not particular instant of time, it is a time period. And r is the factor of radius vector, okay. Radius vector is, as you know, it is there, we have just introduced radius vector is just a position vector or a vector drawn from the circular path, center of the circular path to the position of the object, and it is always varying its position. Since the object is moving, this radius vector is always varying its positions, okay, but its magnitude is constant and direction is always changing, and it is direction is from center to the outward direction, okay. Then we have gone through angular speed, that is omega is equal to angle upon time, that is this angle is considered in time, so theta upon t. So from this equation we have got theta is equal to omega t there, okay. Further, we have taken derivative with respect to some time and we have got certain equations, okay. So as by the definition, angular speed is equal to angle upon time, that is 2 pi by t, okay. Multiplying and dividing by r, we have got some values, that is 2 pi r by t, that is v, and v by r. So we have got the relation with the linear velocity and angular velocity, okay, that angular speed, that v is equal to r omega, okay. This angular speed is having different SI unit, and the linear speed is having different SI unit, that is, as we know, that linear velocity, that is having meter per second, and here angular velocity is having radian per second. Here radian is the unit for angle theta, okay. Also we have studied the centripetal acceleration, okay. We have got the equation for it, the taking the time derivative of radius vector r, that will give you r cos theta I cap plus r sin theta j cap, okay. So if we differentiate with respect to time, we will get a equation in vector form, that is instantaneous velocity v bar is equal to r bar omega. Okay, these are vector form. In scalar form we will get v is equal to r omega. Already we have got here relation. Okay, further if we take second time derivative of this position vector r, we will get instantaneous acceleration. Okay, that is further instantaneous velocity with respect to time, we will get instantaneous acceleration. A is equal to minus r omega square. Okay, A is equal to minus r omega square, as you see here. Okay, sorry. It is coming in between. Let me change this position first. Will it change or it won't? Okay, it's not changing. So here A is equal to minus r omega square, as here minus sign is specifying that the angular acceleration, particularly centripetal acceleration, instantaneous acceleration, is directed opposite to the direction of radius vector. Okay, opposite to the direction of radius vector. Okay, further more formulas we have derived here values, that v is equal to r omega is velocity as we know. Then we will get acceleration as a is equal to r omega square. Okay, this will give equation, as we know omega is equal to v by r, so r into v square by r square, cancelling the terms we will get v square by r. Also v square we can write v into v divided by r, so v remains as it is and v by r as again omega, so v omega is a certain further equations. Okay, all these equations can be convertible. Okay, so the centripetal acceleration, which was due to centripetal force, so further for that also we have got some equations. As we know from Newton's law, force is mass into acceleration. Here again this force is directed opposite to the direction of radius vector, so we have wrote minus sign over there. Here we have substituted the value of A as minus r omega square, so minus m r omega square. In scalar form, force is mass into acceleration, m r omega square. Okay, here we have substituted the value of omega, that is v by r, so v square by r square, r single r cancelled from the numerator and denominator, we will get mv square upon r. Okay, and further again we can write this v square as it v into v, so mv remains as it is and v by r will get you omega, so mv omega is another form. Okay, the last article we have studied in that particular topic, that motion in a plane, was time period of a conical pendulum. So we have got equation t is equal to 2 pi by under root hg. Okay, it is also performing certain circular motion, that is horizontal circular motion. So we have find out there this equation here. As you should remember that for every circular motion certain force was acting and it was balancing forces. Okay, until now we have seen the centripetal force was acting and that particular centripetal force was balanced by centrifugal force. Here as you see, the body which is performing this conical pendulum motion, that is horizontal circular motion, it is also acted by various forces. This is tensional force, then gravitational force. Okay, like this there are certain forces which are responsible for certain circular motion. Okay, in short, in this particular topic, motion in a plane, we have seen circular motion, its definition, characteristics, factor responsible, that is forces, then time period of a conical pendulum. So all well done. Okay, in the next lecture we will start our first articles of this particular topic. Thank you very much.